Hey, let's make sure that's cooking. Okay, so last time we talked about string tokenizer. What does that guy do for us? So string tokenizer allows us to split a string on a collection of tokens, right? All right, so we can, instead of having to write our code that goes through and parses a string and pulling out the things, it basically gives us those tokens, okay? What does the next token method do? It gives us the next token based on the delimiters we put in. So it gives that to us as a string. But what's the consequence of that? Consequence is it actually removes that string from the tokenizer. So if we need to use it in more than one place, we have to store it. Okay, so if we have a tokenizer that tokenizes a string into 3 tokens, the first time we call next token, there's only 2 tokens left. It's burned past that first one already. Make sense? Okay, so something to kind of keep in mind. Okay, so let's continue talking about our arrays that we started talking about last time. We kind of introduced arrays and we talked about this idea of a pointer, and I kind of proved the memory address pointer thing to you. Okay, and a lot of Java textbooks. I know a couple of you have some of the Didle books. I know Didle book kind of at least one of the earlier copies, versions rather, specifically says that pointers don't exist in Java, which is a complete lie. And we're going to continue to prove that today, but we've already seen things that look like memory addresses, right? And I've advertised that a pointer is a primitive type variable capable of holding a memory address. Therefore, by definition, wouldn't we say that AR is a pointer? Wouldn't we say that DR2 is a pointer? Those are all pointers, right? Well, let me get rid of these guys. That was from another class. All right. Retro. Oh, no longer have B. Oh, wrong compiler. All right, there we go. All right, so this clearly looks like a memory address thingy. This clearly looks like a memory address thingy. Clearly, memory address thingies exist in Java. Is this guy a variable? Is this guy a variable? So clearly, variables that hold memory address thingies exist in Java. Therefore, pointers exist in Java. What would be a more accurate thing to say if you were talking about pointers as they relate to Java? Definitely built into the language. Okay, and kind of the next step beyond that is going to be to say we don't have a special syntax for working with them. Okay, so the reason that some of these textbooks say that pointers don't exist is because previous languages required that we specified that we were dealing with pointers. So let me kind of show you this. Let's go out here. VI. Do I have like a hello.c or something? Have we ever looked at this in here? This is us? Yay, nay, maybe? I have nods. Okay, we'll just talk about it again real quick. All right, so this is the example I'm about to give you. Anyway, so this is an old C program. Okay, so we see all programs begin and end with main. I probably started off by showing that at some point. Okay, proving that main has been around since 1968 at least. Okay, that's our evolution of our languages. We went from C to C++ to Java, C#, yada, yada, yada. All right, so main's been there since the beginning. All right, so now we see I have an integer named I, set it equal to 5. Would this line of code identically work in Java? I wouldn't have to change one bit of it, right? Okay, so again, we can probably make this assumption that Java probably came from this guy at some level. Okay, so I'm defining a variable named I. I'm setting it equal to 5, and this guy's capable of holding an int, which this guy is one of those guys. Now I'm creating another variable. Now remember, the generic syntax for a variable is type variable name equals value. All right, so here's a variable named A, and its type is integer pointer. this guy's capable of holding a memory address of an integer. So the value I'm going to give him is the address of I. So here's I right here, holds the value 5. Now, from a programmer's perspective, we think about I as just being a variable and that magically happens somewhere, okay? It's got to be remembered somewhere. Remember, variables are the way human beings solve problems is we remember things. So variables are our way of emulating that. So somewhere in our computer, we're saying, I want to remember the value 5, and the way I'm going to ask for it later is through this variable named I, okay? So we can all agree that that needs to be stored somewhere. Correct? Okay, in our computers, we have our system memory. 2 gigabytes, 4 gigabytes, 8 gigabytes. Anybody have 16 gigabytes in here? The server did not respond. Thank you. Nice evidence that internet's wonky today. Is the internet wonky today? Oh, perfect. Okay, so I was over on this screen, right? Okay, so we believe that we're storing this value somewhere. And in our computers, we store the value inside of RAM, instead of memory. So 2 gig, 4 gig, 8 gigabytes. Anybody have 16 gigabytes in here? Nobody has 16 gigabytes in here? Who in here built their own video game machine? Oh, okay. Wait, other laptop? What's your other laptop? Huh? Oh, so you have a gaming laptop. So why don't you sell that one and just use your Alienware one for everything? Well, how much RAM's in that one? Oh, so it's crap. All right, so realistically, I would say for most applications today, 4 gigabytes is probably plenty. 8 gigabytes is definitely plenty. I don't care if you're a gamer or a Photoshop person or something like that. You know, if you're doing really professional level video editing or something like that, maybe 16 gigabytes will come in very handy. Or if you have a multiple core computer, like an 8 or a 16 core computer that you're using to virtualize 2 separate operating systems where you want to split your RAM in half and have 8 gigabytes for Windows and 8 gigabytes for the Mac, something like that. That's maybe where 8 gigabytes or 16 gigabytes would come in handy. But generally speaking, if you have 16 gigabytes of RAM, you're just showing off. Okay. So there's my 16. And even better, I've had 16 gigabytes of RAM in here since day one, and I got this in 2012. Sick. Well, that was the school's money. I didn't pay for it. All right, so in any case, yeah, I rarely will use a fraction of that. It's the punchline. Okay, so definitely spend money on RAM, but don't spend your money on an obscene amount of RAM. Get at least 4 gigabytes, maybe 8, then get faster hard drives. All right, so anyways, punchline here is this guy's being stored somewhere in our computer's memory. Okay. The creation of this variable here, we're relying on, in this case, the C programming language to somehow create this variable for me, the compiler, okay? And it's going to go and find a place in memory to store that 5. And it's going to somewhere link this variable named I to that 5, okay? Down here, I'm saying I'm going to create another variable named A. And this guy's capable of holding the address of an integer. And I'm going to store in there the address of I. That is, tell me where in memory you've actually put that variable named I. Okay? Now, last time we were talking about the new keyword, right? So the new keyword in Java is used for allocating memory. Remember that? Okay? The predecessor to the new keyword in C was a function called malloc, memory allocate. A malloc. You would just tell it how many bytes of memory you wanted, and it would just go and grab you that much memory. Okay, so in any case, variable named I equal to 5. Variable named A equal to the address of I. variable name B equal to the value stored in A. Okay, the value stored in A is not the address. The value pointed to by A is what this syntax says. All right, so B will be equal to 5, not the address of I. Okay, A is the address of I. Star A follows that address and finds the 5. All right, punchline here for us is in an older language, we had special syntaxes for dealing with address, so dealing with pointers and addresses. Special symbols for doing that crap. Go ahead.
Do you need to say print if, or is it just saying?
This is an older, this is printf is equivalent to system.out.println. The C equivalent of this, okay? So the punchline I want you to get out of this little discussion is older languages like C and C++ had special syntaxes for specifically dealing with addresses. Okay, Java's removed that from us. Why do you think Java took that away? Took some of the children's toys away. Why? This would have been from the slide when we talked about the evolution of Java, when we made the jump from C++ to Java.
They didn't want to be sued by Windows?
I didn't want to be sued by Windows. Okay, no, not that one. When you think about that slide, so probably the very last thing on the slide. So what do we say? In Java, we kept variables, kept arrays, kept classes, kept our objects, still object-oriented language, okay? But we protected programmers from themselves. In C++, you got it?
You don't want to hand people the house from the hand.
That's it. So, in C++, we were empowered to make poor decisions. I use the example about the party probably. If you're inviting somebody over, you don't hand them the house, you give them the address where your house is, right? C++, we could choose to give them the house, okay? Now, Java said that never makes sense. We're going to make those decisions for you. So Java says, we're not going to give you control over memory or not memory. Instead, we'll make all the decisions. Sometimes we'll hand you an address. Sometimes we'll hand you a value. But it's up to us. Therefore, you don't have to have a syntax for working with them. Okay? So Java took away that syntax. Interestingly, if you think about our evolutionary chain thing, dealy flippy thing here. Is that it? Yep. We had this little branch off to C#. I don't think we ever had a slide called evolution of C#, right? Okay, but bottom line is C# brought pointers back in. They allow you to have a syntax for working with pointers, the same syntax from C and C++, but you have to create a code block in C#. Anybody in here ever worked with C# and know what I'm about to say? So you had to create a code block in your code that literally was called unsafe. So you would say unsafe, open curly brace, closing curly brace, then you can do your pointer crap in there. So you specified that bad things can happen here, and I know it. All right, so that was the that was their caveat for allowing you to work with to work with pointers and things like that. Okay, because every now and then in Java, we do run into a situation, especially if you're an old C++ programmer, you're trying to do kind of operating system-y type stuff, where not having direct access to manipulate memory hinders us. We have to have a workaround. We have to figure out another way of solving the problem we're doing. But most of the time, it protects us. Okay, so it probably falls into the category of another reason why I think Java is our best teaching language. Okay, one reason I've already mentioned is it doesn't matter what machine you have. You can all work with Eclipse and all that jazz. Language is platform independent, blah, 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 protects you from yourself. And as a beginning programmer, an intermediate programmer, or even an advanced programmer who's actually an intermediate programmer, like most advanced programmers think they are, you have enough crap to worry about than being able to make additional mistakes. All right, so all of you are already well versed at writing a small little chunk of code that has 5,000 errors. Like, why did I get so many errors when I only wrote 4 lines? Okay, and it's all just one little curly brace or something like that. So you have enough crap to worry about, right? You don't need extra crap to worry about. So I love Java as a first language, but I also like looking at our old languages and see where we've come from, as you've already seen. But down the line, we still use the right tool for the job, and Java is the right tool for certain jobs, but not all the jobs. Okay, so there's definitely a place for C#. There's still a place for C++. If you're going to go into video game design today, pretty high probability you're going to be dropped into a C++ environment. Especially because a lot of the games now, games that are making big money are cross-platform, whether they're Mac and PC or they're Xbox and PlayStation. They're cross-platform, so they have to use a language where they're deploying using something called OpenGL, which is a 3D game engine-y. It's not a game engine, it's a 3D graphic environment for doing stuff. So you'll use a language that'll deploy to both of those. C# would be Windows only. So I guess that kind of crap. So for our discussion here, though, we just understand that older languages had a special syntax for working with pointers. Java does not. Okay, most of our newer languages do not. Swift does not either. Mostly Swift does not either. Okay. All right, so Java, we have the new keyword. We've proven to ourselves today that pointers, in fact, do exist. We just don't have control over them. Okay, so now we want to take this a step further and try to understand the consequence of pass by value versus pass by address. Okay, so this is the house or the address of the house example. So let's call this passing variables and something called a side effect, or you can call it whatever you want. All right, so we can pass by value or we can pass by address. Passing by value sends a copy of a variable, let's see, a variable's value into a function. Pass by address sends a pointer, that is the actual memory address of a variable in memory into a function. All right? So when we talk about side effect here, passing by address is going to have the side effect of changes made to the variable, well, to the value passed will be permanently felt. Whereas pass by value, changes made to the value are local only. Okay? So let's see this in action. Let's get rid of our dice roller guy here. We'll just have our array of integers. And I'm going to go ahead and let's just, we'll say for int I is equal to 0. I is less than ar.length, I plus plus. Okay, so now before I go any farther, tell me what you would suspect length is right there. So we've kind of been going through these exercises of looking at code being used. So this is an example of this guy being used and trying to determine what kind of animal we're looking at. Is it an instance method? Is it a class method? How do you know? Blah, blah, blah. So right off the bat, when you look at length here, what do you think length is? What kind of animal is length to begin with? Something we haven't necessarily said yet, but you're familiar with them. I'm just having you connect some dots. What is length? Give you some options. Okay, is it a constructor, a method, or a variable? How do you know it's a variable? That's how we're calling it. That's going to tell us whether it's an instance variable or a class variable. Why do we suspect that length is a variable? Or maybe a better way of asking it is, how do we know that length is not a method or a constructor? All methods have what? Parameter lists. They all have open and closing parentheses, right? So if we were dealing with a string here, so let's just say we had string s is equal to hello. And then we had a for loop for going through that string. So for int I is equal to 0, I is less than s dot length, I plus plus. So a almost identical for loop, right? For looping through a string versus looping through an array. Almost identical. But when we look at length here for s, we say that guy's a method. We know it's a method because it has the opening and closing parentheses. This guy is not a method because he doesn't have the opening and closing parentheses. Okay? How do you know these guys are not constructors? Based on what we've learned here in the last week about constructors and using constructors when they're called. Let me put up a quick little, so we're going to say, what do I call it, dice roller. All right. What's the constructor in this line? This part right there. This is our call to the dice roller constructor. We're passing it a string, which means we should, over here in the dice roller class, oh, I have it up here, right? Find a constructor that takes a string as a parameter. Okay, see that connection? Okay, so this is where it's being defined. This is where we're actually using it. Now, what's immediately preceding a call to the constructor? New keyword. 100% of the time, constructors will be preceded by the new keyword. Okay? So how do we identify a constructor? Well, we can start increasing our suspicions whenever we see the new keyword. All right? Then often, well, not often, always constructors have the identical name to the class we're constructing in Java. That's a Java specific thing. It's also a C# specific thing and a C++ specific thing. How do creating objects in C work? I've already tried to trick you that once, right? See, she learned. C's a procedural language, not an object-oriented language. Just don't have objects. Star for the day. Let's see. All right, so this guy is not a constructor because we don't see the new keyword, and it also doesn't seem to match any class name that we're familiar with. Okay, it's not a method because we don't see the opening closing parentheses. So we only have one thing left as it involves objects, and that is it's a field. That is a variable that belongs to an object, right? So this guy must be a field. Is it a class field or an instance field? We're going to apply the identical logic to whether or not I would ask the question, is it a class method or an instance method? Is this a class field or an instance field, and how do you know? And this is me using it. Not defining it, I'm using it. Every one of you should be able to just cadence this out there. Are you asking me or telling me?
Calling you?
Telling me. Okay, you think it's an instance. Why?
Because we're not calling the class, we're just calling something that's within the class that we're using. The integer, right?
Well, what's this guy right here? It's an instance. So if we have an instance that's calling something, then that something must be an instance something. Either an instance field or an instance method. There isn't a such thing as an instance constructor because by definition we call constructors when we're building instances, but so we have instance fields, we have instance methods, and how do we call those? We call them with instances. So this guy right here is an instance of this array class thingy majiggy. Okay, so while this doesn't look like our typical constructor thingy, arrays are kind of special purpose type things, but at the very least we still see the new keyword here. Okay, still see that guy probably building some memory. What did we put in memory? Well, we kind of put objects when we use the new keyword directly. Okay, so this guy is an instance field. This guy is an instance method. How do we know this is a method? Because of the parentheses. Yep. 100% of the time, methods have parentheses after them. Sometimes there'll be stuff in the parentheses, sometimes there won't be, depending on whether or not parameters are required, but we'll always see them there. All right, super important skill set. All right, so I realize after I explain it, it makes sense, but these need to be things that are automatic. Okay, when I say, what is this guy, it should almost accidentally spill out of your brain. Okay. That's an instance method. How do you know? Because it's being called with an instance of the class that it was defined in. S is not a class name, it's an instance, so assuming this is not a syntax error, this guy must be an instance method of whatever class S is an instance of. Okay? So, with arrays, we get the length of the array not through a method but through a field, but it gives us the same kind of value. The length of a string here is 5. This will boil down to the number 5. The length of this particular array is 5. This will boil down to 5. The legal indexes in an array are 0 to its length minus 1, just like the legal indexes in a string are 0 to its length minus 1. Arrays and strings work identically from an indexing perspective. Okay, we're the beginning where the end is. Now, what's the difference between an array and a string? And then we'll come back to this passing. What's the difference between arrays and strings? Well, what's a string to begin with? If you had to define a string, what would you say? This is an extremely talkative group. Now, you all realize I already know this stuff, so it's going to be beneficial to you to hear yourself say it. All right, go ahead.
I'd call it a variable that acts out a method.
A variable that acts on a method. Okay, so certainly strings have methods. Certainly strings have methods. So that would be what makes a variable an object. So we're going to say all objects likely have methods. Go ahead.
A variable that holds a bunch of characters.
Yeah, I like that. So a variable that holds a bunch of chars, char primitive types, characters. Yep. Okay, I like that. All right, that's what a string is. Whenever we need to hold a bunch of chars, we put them in between double quotes, and that's a string. Perfect. And then we have some methods, as Jonathan pointed out, that we can use to work with those guys, right? All right, so that's what a string is. Based on what we've learned so far, what's an array? We actually learned about them before we learned about them, right? Because we've referenced them in those slides, the evolution of C and C++ and those guys. So what would you say an array is? We have the identical definition on all three of those, C, C++, and Java slides. Okay, collection of variables. Rather than variables, let's think about the data that's in the variables. Okay, so a collection of data that all must be the same type. Okay, so if we were going to use the string, if we were going to convert that definition over to string, we would say a string is a collection of data that all must be chars. That makes sense? So strings are limited to chars, where arrays are limited to a collection of like data. A bunch of ints, a bunch of chars, a bunch of booleans, a bunch of dice rollers. Make sense? Okay. Anything that we can create a variable of, we can throw in there. So the idea is that what you said, it's a collection of variables. It's the data that's in the variables that goes in there. But anything we can create a variable of, we can shove into an array. Okay. So at the high level, we might use strings whenever we need to hold chars, and we might use arrays whenever we need to hold other crap other than chars. But arrays can also hold chars. Go ahead.
Well, I was going to ask, kind of like an analogy, would a string be like a file in an array being executionable file?
Would an array be like would a string be like a file, and would an array be like executing a file? I don't think that matches at all. So I would say almost think of an array as like a super version of a string. So if we have a generic file that can hold any kind of data, that would be an array, let's say. Whereas if we have a file that can only hold certain kinds of data, specifically can only hold a bunch of characters, that would be so like a text file would be like a string, or a file would be like an array where you can put anything you want in there. Something like that. All right. So in any case, we have, these are our two things. So now we have to ask the question, when should we use a char array versus a string? Okay, so certainly if we need to hold a bunch of integers, we're going to use an array because strings aren't appropriate for that, right? But when we get down to a situation where we have a character array, which kind of has the same exact definition of a string, right? Collection of chars, Are these just equivalents? Are they one just as good as the other? Flip a coin and hope for the best? So this is where it comes in. Very important caveat to strings. A string is read-only. We can only extract chars from a string. We cannot, is cannot all one word? Nailed it. We cannot add strings, or sorry, add chars directly to a string. Capitalize string here just for correctness. If we want to modify the contents of a string, what do we have to do? We've done this in our last couple of assignments. Go ahead.
You have to change the actual string, or change it from a char to an int.
Okay, that's when we're trying to do math with it. I'm saying, so like when we're parsing through our string. So last time when we were doing 13d8, to get the 13, we had to go through that string and build up. Let's just assume everything's fine. We have to build up that 13, right? So we took the 1, concatenated it onto a string. We took the 3, we concatenated it onto the string that already has the 1 on it. So we kept concatenating things onto the string, producing brand new strings, right? Rather than taking a string that has 2 buckets in it and adding a 3rd bucket and putting a character there. Okay, we did not modify the original string. We took one string and another value, glued them together, producing a brand new string. The original string was not modified. Does that make sense? So strings are read-only. When we change a string, new strings are created. We don't modify the string in place. All right. a array is read-write. Okay, an array is read-write. So we can access individual elements of a array in terms of getting the value as well as setting the value. All right, so let's see this real quick. So we have a string name s that just happens to be length 5. So just to actually connect the dots there, if I want to create a new array named AR, and I want this guy to be an array of chars instead of an array of ints, and I want it to be the same length as s, what would I put in there? How many characters are in s? S.length. So I put s.length in there. So now I have a string name s that's equal to hello, and hello happens to have 5 characters in it. And then I have a character array named AR, and this guy is going to be built in a new memory location capable of holding this many of these guys. All right? Java chars are 2 bytes, 16 bits, 0 to 65,535 unique characters. All right, so this is going to create, in this case, 5 times 2, so 10 total bytes of memory. The new keyword is going to go find a home for that out in the operating system and come back and give AR the address. So AR will hold the address where those 5 values will be stored. There's no values there yet. We just have a home for them up in memory somewhere. All right? Now, let's go ahead and let's write a loop that will fill up AR with all the characters in S. So I can write the loop this way. I is equal to 0, I is less than s.length, I plus plus. What else could I put here instead of s.length? What other animal here has the exact same count in it, the exact same length as s? This guy, AR. So I can say AR.length and use the length field. Okay, length field associated with that. So AR.length field or S.length method, both will in this case boil down to 5. Because they were built in terms of each other, right? So they're synonyms, they're the same value. So now what I'll do is I'll go ahead and I'm going to set AR at bucket I equal to, how do I get an individual character from a string? How do I read a character from a string? What's my method, my string method for doing that? Char at. So s dot char at I. Okay, so now I'm going to go through, in this example, this will go through 5 times. I'll set AR at bucket 0 equal to s dot char at 0. AR at bucket 1 equal to s dot char at 1. So on and so forth, all the way up to AR at bucket 4 equal to s dot char at 4. Okay? When we're done here, I'll go ahead and I'll, this is going to be a little bit of a trick, I guess. We'll go ahead and we'll print out S. And then I'm going to print out AR. All right. What's going to be the output for that line? Hello. We've printed out strings plenty, right? Now we're printing out an array. What's going to be the output of this line? Memory address? Okay, because the new keyword was used up here. So that means a memory address is stored here, right? All right, but it's going to print out hello. All right, so hopefully we're all thinking something's not right here. And I'm going to show you the punchline here over in the documentation now. It just so happens that there is a version of the println method that takes a char array as a parameter and prints out the contents of it. All right, so we have a version of println that knows how to print out strings. We have a version of println that knows how to print out ints and chars and booleans and floats and doubles and char arrays. Go ahead.
What's the word for when you write the same function name?
Yep, good one. That's like one of my go-to moves. Love that one. It's called polymorphism. Polymorphism. So we're going to introduce it now. That way I can quiz you on it at some point. And just so you're aware that every year at the CS get-together, which we have one coming up here pretty soon. I don't know the exact date yet, but that's the thing where you can like win iPads and crap like that and get free pizza. This is almost always one of the questions. So polymorphism is when we have a method, well, let's say when we have more than one method with the same name but a different number and or type of parameters. That's polymorphism. Another word for it. Well, you may have learned about it in terms of like method overloading. Yeah, so that's the act of writing another method that, but actually method overloading is pretty specific to inheritance. So the idea would be if you have a global object and you inherit from it, and this guy gets method XYZ, and you wrote your own version of that, you would overload the one that came with it. Or override. Those are sometimes used synonymously. 2 stars, people. All right. So let me show you in the documentation here. We'll see that there's a whole bunch of whatever. That's not what I wanted. Okay, so before I go any farther, just so you guys can help me find this, I want to find the PrintLin method in the documentation. Where might I find that if we extrapolate what this line is? I want to find out where that PrintLin method lives. What is the PrintLin method? Well, we know it's a method, right? We know it's a method because it has the opening and closing parentheses. Must be a method. Possibly a constructor, but we don't see the new keyword, so he's a method. Okay, is he a class method or an instance method? Just got to look one layer out. That's how he's being called right there. Does that guy look like a class name or not a class name? Typically, class names are capitalized, so that looks like it's probably an instance of a class, right? All right, so therefore, if out is an instance of a class, println must be a instance method, okay? But now we have one more layer. It's our first time we've seen kind of things strung together. So somebody else is calling out. What's out? What kind of animal is out? Field, method, constructor. Okay, it's a static field. It's a class field. So out is a field, no parentheses. So it's not a method. And it's being called by the name of a class. We suspect this guy's the name of a class because it starts with a capital letter, naming convention. So there must exist out there a class called system that has a static field in it called out. All right, a variable that has static in front of it called out. And whatever type out is, if I go and look at that object, it's going to have an instance method, a non-static method called println. In fact, we're going to see it has a whole bunch of those. All right, so we're going to go on a little wild goose chase now. We're going to go in the documentation. We're going to go and we're going to find the class called system. And then we're going to find the field called out. And then we're going to go into the object that out is an instance of, and we're going to find his println methods. Okay? I do it this guy? Okay. So I'm going to start off by, we have all the classes here, so we can scroll down and find system in there, but I'm going to shorten it here. Just go to java.lang. This is the core Java programming language. I feel like I clicked on it. I'm very certain I clicked on it. right, we'll have a race here while that's cooking. So I'll scroll down here to where the S's are. Oh, it finally changed. We're good. All right, so now I'll click on System. All right, so this is our System class. We'll look under Fields. We see a field here called Out. This guy is of type println, and as he suspected, it has static out front because we were calling it with the name of the class. I'll go ahead and click on println. So inside println, we expect to find a whole bunch of println non-static methods. Here's a println, here's a println, here's a println. So here's an example of polymorphism. Each one of those methods has the identical name, the identical return type, but a different number and or type of parameters. We have one that takes in nothing, and this just kind of spits out a blank line. We have one that takes in a Boolean, one that takes in a char, one that takes in a char array. That's why this particular guy printed out hello from our char array rather than the memory address. We have one that takes in a double, a float, an int, a long, a generic object. Generic objects are going to ultimately call that object's toString method. All right, so we'll see this here in I'll kind of fill in the gap here in a few minutes. So by default, every single object is guaranteed to have a toString method because it will at some level get one from the global object, okay, called object. And that guy's toString method returns a string representation of a generic object which looks like a memory address. Okay? That's why most objects, when you just print them out with println, show a memory address. Because we haven't overloaded the toString method with our own version of it. Okay, we'll see this here in a few minutes. I'll connect that dot. Then we have one specifically for strings that prints out the contents of the string instead of the memory address. Okay, even though strings are objects, they're a little bit more than an object, and they've written their own version of that toString method to print out the actual contents of the string. Okay. So, as an example, if I had created an integer array called AR2 and set this equal to a new integer array of size s dot length, so AR2 will be the exact same length as AR, which is the exact same length of S, and we go in here and we set AR2 at bucket I equal to I. So we'll fill it up with numbers. Can't put chars in there because he's built for holding ints. They'll scream at us if we try to put chars into an array for holding ints. All right, and then I come down here and I print out AR2. We're going to get hello, hello, memory address. Because there isn't a version of println that knows how to take in. Well, there is one that knows how to take in a string. There is one that knows how to take in a char array, but there isn't one that specifically knows how to take in an integer array. So it's going to call the generic object version of that method, which just calls this guy's generic toString method, which evidence has indicated just spits out the memory address of the guy. So we'll go ahead and run this. We get hello, hello. Where did I screw up? Oh. Just like curly brace diarrhea, sometimes we get parenthesis diarrhea. All right, so there we have hello, hello, memory address. And you can kind of see how Java handles their fake memory addresses, because Java runs inside of a virtual machine, so they kind of create their own memory model that sits locally within the Java virtual machine that kind of talks to the actual operating system. It kind of links to it through system calls. So we can tell that this guy must be an integer array because Java, arrays have the little square bracket at the beginning, then a capital letter indicating the kind of type that's in there, and then the at. So it lives at this memory address inside of the virtual machine. more trivia information for us, but that's the breakdown of what we're seeing there. Okay? All right, so println knows how to print strings. It knows how to print char arrays, which is what tricked us. Doesn't know how to print any other kind of array. Just char arrays, because char arrays kind of like strings. Okay? In fact, we've talked about the use of string array args in our computer programs, right? I think you look at Java here. Haven't we gone through and looked at what this guy's used for? And seen that we can read in command line arguments. If we run our Java program, we can pass it cat, dog, whatever, and it'll come in to this array of strings, and we have access to those things if we were to run our Java program from the command line, right? In Java, our command line arguments are represented as an array of strings. So now we know what the syntax means. It's a string array that we've called args. So we know that this variable is going to hold a collection of 0 or more strings. All right. Now let's look at an older language like C. First of all, notice here's our string array. It's represented as what's called a char pointer pointer. So an individual string is a char pointer. Okay? It points to the beginning, the memory address at the beginning of a character array. That's how a string was represented in C. That's how strings are still represented today. We just don't have to deal with the funky syntax. All right. Similarly, a char pointer pointer says we have an array that has inside of it a bunch of char pointers. All right, and each of those char pointers points to the beginning of a char array, which holds the contents of a string. All right, punchline being that strings are character pointers, collections of characters where we have to start at the very beginning of it and walk to the end of it. But in C, we have a second variable here, argc as an integer. Arrays were stupid in the C programming language. Okay, they didn't know how many characters lived within them. All they knew was what memory address it started at. So we had to have a second parameter that got passed in that told us how many command line arguments will I find in here, so I know how many things to look for. Because this guy that I have highlighted can't tell me how many things it represents. He's just a giant blob of memory where one bucket doesn't know, the left hand doesn't know what the right hand's doing. So I have to have this other value that tells me how many things are in this blob. Make sense? Java, as we've seen today, our arrays have a length field that can tell us how many elements are in the array. So we could say that Java has an evolved array. I know Dr. Locklear hates me using the word evolved, but whatever. I don't have a better term for it. All right. So punchline is that's the scoop, and we can see kind of as our languages evolved. If we were doing this in C++, we would see this would be a char pointer. Actually, it would be. This is fine. Char pointer array called argv. So now we start seeing that array syntax pop into existence in C++. The open close square bracket. And this guy's going to be an array of char pointers. Or similarly, we could write this in later versions of C++ as a char array. This is an array of char arrays. Okay? But in C, we keep it nice and cryptic with the pointer syntax, so char pointer pointer argv. All right, so this is kind of an example of how these things have evolved a little bit. All right, so back to here. What were we? All right, so that was the polymorphism. That's why we had this guy print out some different kinds of values than maybe we expected. We probably expected a square bracket C at thing here for our character array, right? That's probably what we expected. Let's see, is there a way for us to force that? I think so. I can probably say, you are actually an object, trust me. There we go. So there's our C version of this. So I told this guy, this is called typecasting. So I said, AR, you're no longer, even though you are a char array, I want you to go in costume as an object, a generic object. So when the println method receives that and they're trying to figure out which version of the println method to call, he's going to look at this and say, oh, here's a generic object, call that version of it. That makes sense? So I called a different version of the println method because I dressed him up as an object here, as opposed to a char array. All right, so there, again, you see it's char arrays are represented as memory addresses just like integer arrays are. All right, so now let's deal with side effect, what we were talking about a few minutes ago. Oh, actually, one more thing before we do that. Let's just deal with our dice, that toString method I mentioned. So let's introduce it here in the slide first. So all objects have a toString method. By default, this method is inherited from the object class. Let's call it the generic object class. And it returns a string that is a string representation of the object's memory address. Right? So every single object in our programming language, every single object in Java is guaranteed to have a toString method because one was provided to us at the very, 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 very top of the object-oriented chain, the hierarchy, if you will. At the very top, we have this guy called object, and we'll see this here in a second. So there's some hidden stuff. Remember when we talked about Java, one of the things I said I don't like about it from my teaching language is it hides crap from us. Okay? Because it's a power tool. It's made life easier for us, but as programmers who want to learn the programming skill set, not just learn Java, it's important that we understand what's going on. So when we say public class dice, there's something hidden right here. What's hidden is extends object. All right, so we're creating a object here called dice. But what actually makes him an object to begin with is the fact that he's taking our generic object and he's extending it to be something a little bit more special. That is a normal object that also keeps track of a number of sides, has a name, keeps track of a random object, and then has his own constructor and some methods. Okay? So we're taking this base class object and we're extending it to be a little bit more. All right, so this will still work. This is not going to break if I leave that there. It's assumed to be there, and if we don't write it, it is there. The reason why is I can say that a dice actually extends, let's just say extends, let's say I had another object called blah. All right, so if dice extends blah, blah extends object. So we have three things in the hierarchy then. Okay, so this guy extends object. And even though I haven't shown you this yet, let's just prove this first. I'll go ahead and create a, what does the constructor for dice take? A number of sides, okay? So we'll go ahead and create a variable of type dice. Dice D is equal to a new dice, and we'll go ahead and pass this guy a 6, whatever. All right, and then if I come down here, let's just print out D. So we'll only have one output for our program here. So D is a dice. When I print out D here, what would I expect to see? Right now, we're kind of in memory address mode, right? Probably a memory address. All right, so this guy is going to be a dice memory address. So there's the dice at this creepy memory address. All right. Now I'm going to elaborate on this. So which version of println do you think that guy called? Probably not the one that takes in an int, or a double, or a float, or a char array, or a string. It's going to call the one that takes in an object. Because dice is an object. That's what he is. He isn't any of those other guys, so this is our catch-all. All right, so what that guy's actually doing is this. There's D. I'm calling his toString method. So toString in this case is a method because it has the opening and closing parentheses. It's an instance method because I'm calling it with an instance of a class. Yet when I go and look at dice, I don't see that I've written a toString method in here. I don't see that, right? That means I got it from someplace else. I inherited it from my parent, which is object. So if we go back to the documentation here, and I go to find the object called object, we see that in object we have a whole bunch of generic object stuff, and one of the things is a method called toString. This guy right here. All right, so that's the method that's getting called. So out of curiosity then, as I have it written right now, which version of println is getting called here? This is the toString method. What does the toString method boil down to? String. So which version of println is getting called? The one that takes the string parameter, no longer the one that takes the object parameter. Because even though it might at first glance appear like I'm sending in an object, in fact I'm sending him the result of that object calling his toString method, which is a string. Make sense? But this proves to us, if I go ahead and run this, that we'll get the same output. Okay, this proves to us that the object version of println, the one that just takes in a generic object, must just return, or must just display, whatever object you passed in, whatever's returned by his toString method. Make sense? That's what it's actually doing. Okay, because we see we get the same kind of output. Okay, which then means that I can come in here and I can override this guy, so I can say public string toString, and I can return this dot name. So that's going to be like D4, D6, D8, those things. So I just wrote my own version of toString, which overrides the one I got from my parent. All right, so I have a more local definition of toString. We already said all variables resolve to their most local definitions. All methods will resolve to their most local definition. All right, so when we say D, call your toString method right here, now it's going to print out D6, the name of that dice, because I have a more local copy of it. Okay? If I want to really jazz it up, I can return that guy with the string, open parenthesis, and let's just throw a closing parenthesis there on the end. And then in the middle, let's call super dot toString. So I'll go ahead and let my parent's version of toString join in here. So this is how an object refers to itself from within itself. Super is how an object refers to its parent. Okay, so now I'll get whatever's returned by my parent's toString, which will be the memory address thingy, and I'll go ahead and tack it on as inside parentheses after my name. So if I run this, now I'll get D6 with the memory address afterwards. Kind of make sense? All right, so for homework, now that we've seen that we can get values, so let me just quickly show you that. So let's just do AR2 at bucket 3. So we'll print that out. That'll be the fourth element inside of our integer array. So we can get stuff from an array in the exact same way that we can say AR2 at bucket, sorry, let's go down here. AR2 at bucket 3 is equal to a -7. And then I can print this line again. So I can read and write arrays. There's my 3, there's my -7. I change the value of that guy. Okay? So what I want you to do is write a method, and we can make this a static method inside of our driver class. We'll bounce back and forth between those. That takes an integer array as a parameter. Go ahead and fill that array up with random numbers, and then sort the array. And I'm not asking you to use any sort of sort you've learned. I don't want you to use any built-in sort things. I want you to say, if I have 10 values that are laying in front of me, what kind of ghetto solution might I come up with that sorts those values? Try to stumble upon a way of sorting some values. Figure out what the smallest number is, putting it at the top. What's the next smallest number? Putting it in the second spot, so on and so forth. So trying to figure out an algorithm for sorting some values. That make sense? All right, I'll put that up on Blackboard, and I'll see you on Tuesday.